Welcome to our video on the law of sines and cosines. In this video, we are going to show you guys how to solve triangles using these laws. First, let's define the law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of angle A. This formula is very useful when you are given two sides of a triangle and an included angle. It can also be used when you are given all three sides of a triangle. Using the law of cosines, we can solve the whole triangle. This means that we can find the lengths of all three sides and the measure of all three angles. Now let's do an example. Here we have a triangle with two given side lengths and one included angle. Let's call this side side B and this side side C. As we know, a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Using substitution and plugging in the values that we have into this equation, we can solve this to find side A. So, a squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 49 degrees. Using your graphing calculator, you will find that a squared ends up being about 28.075. Taking the square root of that, we find that a equals 5.29 units. And now we've solved for side A. Now that we have the side length of side A, we can use the law of cosines, as shown here, to find the measure of angle B. By plugging in the values of sides A, B, and C into the law of cosines, we find that angle B is 45.41 degrees. As we know, there are 180 degrees in a triangle. To find the value of angle C, we can subtract the values of angles A and B from 180 degrees. This shows us that angle C is 85.59 degrees. Let's try another example. In this example, we have been given the lengths of all three sides. Let's call this one side A, this one side B, and this one side C. This is angle A. The law of cosines states that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Plugging in the values that we already know, 8 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of angle A. Skipping ahead a few steps, we find that the measure of angle A is equal to the inverse cosine of 1/4, which is approximately 75.52 degrees. To continue solving for the rest of the triangle, we can use the law of cosines and our three given side lengths to find the value of angle B. Once again, we should remember that the total number of degrees in a triangle is 180 degrees. So by subtracting the values of angle A and angle B, we can find angle C. Using this method, angle C comes out to be approximately 57.91 degrees. Now you've solved for another triangle. Great job!
Now let's define the law of sines. This law is useful when we know opposite angles and sides. Side A is opposite to angle A, and side B is opposite to angle B. Lastly, side C is opposite to angle C. You can use the law of sine when you know two angles and one opposite side. The equation consists of 3 parts, and to solve for something, we can take 2 of those 3 parts and set them equal to each other in a proportion to solve for an unknown variable. If we know 3 of the 4 parts in a proportion, we can solve for the last one. So, for example, say we know the measure of angle A and side A. We also know the measure of angle B, but don't know the side B. Suppose we want to solve for side B. You would then use sine of angle A over A equals sine of angle B over B. Plug in the information you know, which is the measure of angle A and side A, in the measure of angle B, then solve for side B. Let's look at an example. For this triangle, we know 2 angles, angle B, angle C, and also we know one side, side B, which is opposite to angle B. This means we can use the law of sine to solve the triangle. Suppose we want to solve for side C. Remember that the sides are opposite the angles, and so this is side C right here. So let's take a look at our formula again. We know angle B and side B, so we can use the sine of angle B over B part of the equation. Then we also need to include the part with the side or angle we are looking to solve. We know angle C and we want to know side C, so use sine of angle C over C. Then set these equal to each other. Now, all we have to do is plug in and solve for side C. Angle B is 70 degrees, and it's over side B, which is 15. We set that equal to sine of angle C, which is 45 degrees, over side C, which we are trying to find. Now we cross multiply. Then we divide both sides by sine of 70 degrees to isolate the C. Now plug in 15 times sine of 45 degrees divided by sine of 70 degrees to find side C. You should get approximately 11.29 when you round to the nearest hundredths. To solve the whole triangle, we should also try to solve angle A and side A. We still know angle B and side B, so let's use sine of angle B over B again. Then we'll set it equal to sine of angle A over A because it contains the parts side A and angle A that we are interested in solving. We don't know 2 of the variables, the measure of angle A and the side A. That means we can't solve it, at least not yet. We need to solve for the measure of angle A so that we'll only have one unknown variable and can use the law of sine to solve this. Because we know the sum of angles in a triangle is 180 degrees, to find the measure of angle A, all we have to do is subtract the measure of angle C and the measure of angle B from 180. 180 minus 45 minus 70 is 65. So the measure of angle A is 65 degrees. Now that we've done that, let's plug everything in. Angle A is 65 degrees, so we write sine of 65 degrees over A. Angle B is 70 degrees, and side B is 15. Then we cross multiply again. Divide both sides by sine of 70 degrees to isolate A. A is about 14.467. The triangle is now solved.
But wait, there's more. Let's learn about the ambiguous case. As you know, side triangles and side angle triangles guarantee exactly one solution for the triangle using the law of cosines. Angle side triangles and angle side angle triangles, as well as the hypotenuse leg, also only produce one triangle using the law of sines. However, SSA, or side angle triangles, are tricky.
As you can see in this example, we can make two triangles when we know two sides and one non-included angle. We know the measure of angle C, side B, and side C. If we draw a line segment from A to B prime, it makes an obtuse triangle. If we draw the line segment, however, from A to B, it makes another acute triangle. So, which is it? Well, we don't know. So let's solve for both cases.
First, let's try using the law of cosines to find the two potential lengths of the third side. We know that side A is 10 units and side B is 6 units. We also know the measure of one non-included angle, 33 degrees. Substituting these values in, we now have this. This then becomes this. This looks familiar. You can now use the quadratic formula to find the two potential values of the third side. B equals 10.90 and B prime equals 5.87. It is important to know that when you have an ambiguous case, it is possible to have two solutions, one unique solution, or even no solutions. You can determine what kind of solutions are possible by finding the discriminant of the quadratic formula. If the discriminant is negative, there are no solutions. If it is 0, then there is one unique solution. If the discriminant is positive, like in this example, there are two different triangles.
Now let's see how we would approach this problem using the law of sine. Let's just solve for angle B. We know angle C and side C. We also know side B. So let's use the sine of angle B over B equals the sine of angle C over C. Now we plug in. We don't know angle B, but we know side B is 10. Angle C is 33 degrees and side C is 6. Now we cross multiply again. Divide both sides by 6. Then, using your calculator, find the inverse sine of 10 times sine of 33 degrees divided by 6. Angle B is about 65.19 degrees. But remember, we said that depending on how we draw side C, we can make an obtuse and acute triangle. This solution for angle B would make it an acute triangle. To find the obtuse alternative, you subtract what you got for B from 180. We subtract it from 180 because that is its complementary angle. Angle B could also be about 114.8 degrees.
Thanks for watching and happy mathing!